Let us compare the principal values of trigonometric and inverse trigonometric functions. On the left side I have given the trigonometric function, its function, principal domain, range. On the right hand side we have inverse trigonometric functions with the inverse function, domains and the range of principal value branch. For sine function, the principal domain is between the closed interval minus pi by 2 comma pi by 2, and the range is between minus 1 comma 1. Then for the same inverse function, sine inverse, it is just the domain becomes minus 1 comma 1 with a closed interval, and minus range becomes minus pi by 2 comma pi by 2 within the closed interval. Similarly, we can write down for cosine, that is cos, then tangent, and then for cosecant, then secant, and then cotangent. So let us write down for cos. For cos it is 0 comma pi, the principal domain is 0 comma pi with the closed interval, and range is a real number. Whereas the cos inverse is just ulta. This is the real. I'm sorry, that is 0 pi, and here it is not real value, minus 1 comma 1. It is like sine only. And here it is reversed, that is minus 1 comma 1 with the closed interval. And here 0 comma pi becomes the principal value branch, the range of principal value branch for cos inverse. For tan inverse, within the open interval, sine is closed interval, this is open interval, otherwise the values are same, minus pi by 2 plus pi by 2, but open interval. And here the real number, but the tan inverse is just ulta, real number, and this comes as the range, minus pi by 2 comma pi by 2 with the open interval. Now for cosecant, minus pi by 2 pi by 2, it is similar to sine, however excluding 0. Okay, so 0 is not included. And here for cosecant, the range is a real number excluding minus 1 and 1 in the closed, open interval. And for cosecant inverse, it is just ulta, that is real number excluding the open interval -1 to 1. And here the range of principal value branch of cosecant inverse is minus pi by 2 comma pi by 2 excluding 0. Okay, and then similarly for secant. For secant, it is like cos 0 comma pi with the closed interval, but excluding pi by 2. Okay, and similarly to secant, so range is a real number excluding -1 comma 1, whereas secant inverse is just ulta, it is or -1 comma 1 excluding minus comma 1, and here 0 to pi excluding pi by 2. Are you able to follow? Then cot. So cot is 0 to pi within open interval, or is the real number is the range, whereas in the case of cot inverse, real number is the range, domain, just ulta, 0 comma pi is the open interval, is the range of principal value branch of cot inverse. Okay, so how you can remember this? For sine minus pi by 2, pi by 2, and the range is -1, 1, it is ulta. So for all inverse functions, range, domain and range are interchanged. So that is the way you can remember. So in that case, you can remember only trigonometric function and interchange the domain and the range. That's all. Got it? Now, as far as trigonometric functions are concerned, sine and cosecant, they have the same, that is a principal domain, but in the case of cosecant, that is the reciprocal value of sine, it excludes 0. Similarly, for cos and secant, it is a closed interval of 0 and pi, but in the case of secant, excluding pi by 2. For tangent, it is minus pi by 2 comma pi by 2, but cot is 0, pi, and the respective ranges, sine range is -1 comma 1, and cos range is, cosecant range is real number excluding -1 comma 1. Similarly, cos is -1 comma 1, similar to sine, but secant is excluding or excluding -1 comma 1, and tangent is a real number, cot is also a real number. So this is the case with the principal values. Okay.